Hey there. Let's continue refactoring Futurecam. This time we'll look at this function. Can we remove it? So let's remove this first of all, and its collar. We'll figure out where to put it. And of course, as always, failure is an option when refactoring. If it doesn't work, we can always go back. So think of a refactoring as an exploration. And when you start exploring, you don't say ahead of time that it has to succeed. That's making it too rigid. So let's not do that. Oh, we don't need this anymore. Okay. So if you look at the divs, the code that's commented out or deleted rather, one case is photo output. Let's look at this case. There are two modes that use a photo output and two modes that use a video data output. The two modes that use the photo output are time-lapse mode and long exposure mode. So let's see what we can do about these. Since this is no longer part of the protocol, we don't have an override for this. We should reevaluate this function. This app was quite a challenge to build, partly because it's a very high performance app. It processes a gigabyte of data every second. And when you build such an app, you're really exploring the limits of the hardware and the software. When you do that, a lot of things go wrong. And when they do, you add a lot of assertions to make it work. But over time, once it stabilizes, you should reevaluate. Let me say reevaluate. It's less committal or it's non-committal, right? Because again, you do these reevaluations with an open mind, not with a conclusion already in your mind that we should remove this. All right. So the advantage of filing tasks like this is you are not sidetracked from what you are doing. So after you have done all, one more thing. Again, notice these are questions, not answers. Alright, so here we need to add this thing that we removed. Obviously, long exposure mode is not burst mode, and obviously it has photo output. This ensures that we are the active mode. So let's say the user is in long exposure mode, and after that he goes to some other mode like a time-lapse mode. Then the long exposure mode should not stop recording because the user went to the background. And from time-lapse mode, if the user comes back to the long exposure mode, a different long exposure mode instance is created. So it's not just a question of which class is it, but also which object is it. We don't need to check that we have photo output. Of course we do. We don't need to check that it's not burst mode. It is not. It's long exposure mode. We don't need to check that stop recording doesn't work or doesn't cause a problem if it is not already recording. So all those cases are taken care of. All right. We can probably put the same code in self dot. We can probably put the same code. Oh, this is not mode, this is self, sorry. When you copy paste, the self reference changes. Here self is the mode. Earlier it was the camera. So which is why you access the camera this way. You don't need even self dot because you have a local variable. So camera dot mode is self, else return, and then stop recording. We can copy paste the same code in time lapse mode. And where is stop recording? Oh, stop recording is in abstract video mode, which is not an override anymore. Okay. The convention is 4 blank lines and we'll maintain it. Okay, cool. We should look at new features of Swift and ask how we can help improve. Evaluate. Can we use implicit return in current Swift? Because if you have a function which has only one line of code, like return something, I think you can remove the return keyword nowadays. Anyway, we should find and fix all this. Okay, there's only one. This again overrides on the abstract video mode. So time-lapse mode and light trail mode, if they have stop recording, should override. Okay, we'll get to this. Looking at the diffs, we have taken care of time-lapse mode. And long exposure mode. These are the modes that use photo output. Next, we'll move on to the modes that use video data output. we don't need to check that it has video data output or that it's not burst mode. Instead, as before, we need to check that camera dot mode triple equal to checks identity rather than equality, which is to say it compares the object pointers. So if there are two objects with the same values, it will return false because it's not the same object. Okay. We do have a stop recording, do we or do we not? I think we should remove this else's with verifications. Anyway, that's a different conversation. How do you stop recording? Oh, when the shutter button releases, you stop recording. Next, we need to take care of the light trail mode. Again, we don't need to check for photo output versus video data output. Okay, let's look at our work. In camera, we have removed this meaningless or rather dead code. We are observing these two notifications. Photo output users did enter. Here we are using did enter. Here also we should be using did enter, yes. And in both cases we have a stop recording function which we invoke, because when you invoke a function you have to check that it's there. We invoke it already, so it should be there. There it is. Okay, now let's look at the classes that use video data output, which would be light trail mode and burst mode. Here we need to observe will resign, not did enter. So there are two ways of going to the background. Basically what happens is that iOS first invokes will resign actor. So let's say you are in the app and you get a call and you get this full screen UI with the accept and decline buttons. At that instant, iOS sends this notification saying you are no longer active because somebody else has come in front of you, some other app or whatever, the system UI. And then if the user rejects the call, you are back to the app. If the user accepts the call, then the app is moved to the background, then you get this notification. So in some cases, we need to stop recording in the first stage, in some in the second stage. This is also something we need to figure out. Why are we doing it? Can we handle both the same way? But anyway, so now will resign active should be used with video data output, which is used in light trail mode and in burst mode. So you can see how clean this code is as opposed to which is the one, hold on. We had messy code in mode, was it? Yeah, this is the older code. Hey, oh no, it's not background task. Hold on. Yeah, inline observers. This is the one. Clean up the background observers. So here in camera.swift, you had this complex code. You would register observers and then you would do, look at how complex this is. There are multiple scenarios, there are multiple guards. One is for video data output, one is for photo output, and then there are two variables and you're removing and you're adding and the nested if statements within the guard and so on. By contrast, see how easy this is to understand. So sometimes if you have a giant piece and you break it into smaller pieces, it becomes easier to understand. It's like if the complexity of the original thing is 100 and you break it into 4 pieces, each of them has a complexity of 10 for an overall complexity of 40. So you have reduced the complexity of the app, which is the case here. On the other hand, it can happen that you have something with a complexity of 100 and when you break it up, you end up with 4 pieces of complexity 50 for a complexity of 200, which is an increase in complexity. So you should not do that refactoring. Again, it's apparent only after you do it, which is why you should think of a refactoring as an exploration, not a commitment. I hope there aren't any calls to stop recording which we need to take care of. No. Remove. Okay. Verify. Oops. Yeah, we shouldn't have this. Firstly, it's static, which is not good, even though it's just a verification. Secondly, it doesn't trigger. Thirdly, if you forget to call this and you create another instance, anyway it checks. Remove this since the initializer anyway checks. We had some else cases that only have a verification. I'm trying to simplify the code because too many if else's makes it hard to understand. Was it here in one of the modes? So it's good to see this. This logic is still the same. If you're recording, you stop recording, otherwise you start recording. Except that start and stop are no longer in the mode protocol. They are an implementation detail of the mode, which is a better design. This is probably good to keep for type safety and also to convey to readers that we did take care of this case. I don't mind these verify statements. I'm just concerned about verify within if. Okay. Let's look at the non-photo modes, which are the long exposure mode. I think this is a little too nested for my preference. Okay, never mind. Let's not do that. So let's take a stab at this task. Oh, this is done. Make mode a minimal interface. Let's delete it. Can session call start running by itself? Is this code good? This should be called only in the modes, and it is, yes. And I think in all the mode initializers, yeah, why do we even need this preferred camera? We need to think about that. Okay, we'll get to that in a second. Defer code is hard to understand because it breaks the flow. What are you doing with the device? So let's first configure the device. This code doesn't have any apparent logic to it. You're throwing a bunch of things together and stirring them, and you don't want a code salad. First configure the device. So things should be done in some kind of logical order. Before you configure the device, you lock it for configuration. Then you set the full res format. Then you unlock it for configuration. Now the device is fully configured. Now that the device is fully configured, add it to the session. Here defer doesn't work when you want to write code that executes in the middle. Defer executes at the end. Add it to the session. Now you can get rid of the defer block since it's at the end of the code anyway. So in general, in Swift, when you lock a resource, you are encouraged to use defer to unlock it. So if you write code like this, func do something, some resource dot lock, and then you have some code here, and then you do resource dot unlock. This is tricky or dangerous because in the future someone may refactor this to do this. And then you are not unlocking in this case. So Swift convention is to do it this way. This guarantees that as soon as this is executed, you are executing the guard without any intervening code between these two. Now this guarantees that the resource will be unlocked, which is good. But the problem is it leads to harder to read code. So when you read this code, it's much harder to understand because you have multiple defers and they execute in reverse order and so on. And we are also adding the device to the session before it is fully configured, because you have to unlock for configuration to commit the configuration. Then you should add it to the session. So you can see the order also gets kind of broken. This happens because it's not obvious. Convoluted code has surprises. So I deconvoluted it. First configure the device, lock, do something, unlock. Then you add it to the session. You begin configuration, you do something, then you. And the way you lock the session is different in different cases. Here you begin configuration, here you stop running. Okay. This is an independent logical unit of work. This is not what we set out to do, but this was a part of what we set out to do. So let's commit this. This is how you change modes. What happens when you init? Trying to figure out where the camera is changed. It's changed at the UI layer, which again makes sense. It makes sense because the UI control needs to be updated. So now if you do it at the photography layer, which is the business layer or the model layer, you have to have a call back to the UI layer. So now you have calls in two directions. When the user changes something by tapping it, you have to call down from the UI layer to the model layer. And when the model layer spontaneously changes the camera, you have to call up to the UI layer, which is tricky. It can lead to infinite loops. It's harder to understand. Better do it at the UI layer. we should have a task to reevaluate defers. This is a situation in which having running code, having a compiler helps, because I would have set a breakpoint and figured out when something happens, but that's okay. So basically what I'm trying to do is, why do we need to have special case code here? Can the session itself start running? In general, I like classes to take care of itself. There should be less coupling between classes where one class has to inform another class. Can we do this? Defer if input extension AV capture session. You have a device. If device input not equal to nil, start running. So the logic here is, you start, so in general you are supposed to configure the session, fully add an input and an output, and only then start running. You shouldn't call start running and then add an input, or add an input then call start running and then add an output, because the session has to reconfigure itself. So in add output, since when you write code, if you find yourself explaining to someone, stop and see if you can write it in a comment. Check if we also have an input, in which case we can start running. So now we have removed it here. In both cases we are running. First you are removing, when you are adding an input, oh, there may not be an input. The first time it's added, it will be null. Okay. Yeah, this code will obviously crash because you have to call add input the first time before you add an input. Do you even need all these local variables here? Because you have a device input accessor. So you're iterating through all of them, and if any of them are different from the one that's being added. Okay, yeah, that's still fine. This should work. So suppose you have the wide camera and you're adding tele, it will iterate through all of them, which will be wide and tele, and oh, it's a different input, huh? Wait, you can't remove this because this is a different input. You need to be careful here. So these two are the existing input and the device within the session. These two are the new ones to add. So let's take a stab at this. Instead of iterating over the devices, can we iterate over the device inputs? For, I think the AV capture session has a property called inputs. Here, inputs. So can we iterate over them? For existing input in inputs, which is not a name that conflicts, this is input, this is inputs, and these are other names, device input and device. Where existing input is different from the given input, remove is a helper function. Yeah, you don't need to do this, you can just remove input. I think that's what it's called. Remove output, remove input. We don't need to go to the device. So this is the hierarchy. You have an AV capture input, which is any kind of input that you can add to a session. So a session is like a central object. If I could just draw, this is like a session. And then you can have AV capture input. So you can have multiple inputs, like a mic and a camera, for example. And then you can have an output. Right, so the session is like the central thing. Now, one of the subclasses of AV capture input is AV capture device input, which represents input from a physical device, as opposed to, I'm assuming, a synthesized device. So in the earlier code, we would check the device, but now we can just work at the input, which is easier to understand because you don't have that level of indirection. And this is also good because it doesn't change based on the camera. So tomorrow if Apple adds a new camera like a monochrome camera, you don't need to update this code. That's the problem with hard coding, or an infrared camera or whatever kind of camera. This is generic code. You just go through the existing inputs which are different from the current ones and remove them. Okay, now you have removed this. So again, we should configure the device before adding it. So here we are adding it and then configuring the device, which is bad. Let's see what we have done so far. Yeah, here also we should call start running. But first let's commit this alone. It's okay. I don't want to save files and undo, redo. We don't have an early return here, so we can do it at the end. If outputs array is empty, okay. If the outputs is not empty, start running. No, I think we're doing too many things here. First, we should just do this. So this is what I'll do. I want to commit only this change. This thing about removing this call will happen later. Yeah, I'll just do it in the online version of VS Code, I guess. The other way is to copy paste this and revert the unnecessary changes. Yeah, let me do that. I've copy pasted this, so now I won't lose it. Is there no revert? Oops. So if we commit just better session, we are fixing the crash. This will crash because it's nil. This won't, because we are just iterating through an existing array. We are not dereferencing anything. And this checks this alone. So this change doesn't need to be committed because we are not using these two properties here. And is this remove function even used anymore? No, it's just defined and not used apparently. What? Oh. See, See, only 1 of 1. That is a safe change, removing dead code. And even if we do have a caller to that, the compiler will complain, we can go to revision history and copy paste. Okay, so what is the change? Hey, what happened to the... I think the diffs are broken. VS Code's Git integration is defective. Beta session. So here, the first time this runs, it casts input to device input, which is fine, the local variable. Then it accesses the device, which is also fine. Then it removes all of them by iterating through the inputs, which is also fine. So this is more of a simplification, I guess, because since this is invoking the argument, it should not be a problem. If it were invoking self.input, then it would be a problem because it crashes here. So this is probably not a null fix, it's probably just a cleanup of the code. Like the earlier code also works, it doesn't throw an exception. Still good because you are removing this helper function, and you are just working at the inputs without poking into the input and asking what device do you have, which is just unnecessarily convoluted. So let's just commit this. Deconvolute session.add input. Oops. I just want to make sure that the staging worked correctly. Yes, only one file got committed, showing one changed file. So you can see, right? One line got added and 19 lines got deleted. This is a good commit. If it were the other way around, it would be bad. If it were 19 added and 19 deleted, you should start to ask, am I really improving things or am I churning from one to the other, which is an unnecessary change. And you don't even have this operator, because whenever you see this operator, you will stop and think, will it crash at runtime? This is type safe code. And like I said, it doesn't depend on which cameras an iPhone has. Okay. Yeah, these were the other changes. No, but before that, here also, let's fix the other problem, which is we need to configure the device first. Now that we are not using defer, the device is configured at this point. We don't need so many blank lines here. I removed this blank line so that now this comment applies to this entire block as it should. So when adding an output, first we configure the device. Then we add it to the first we configure the device. At this point the configuration is done, the device has the correct state. Then we add it to the session. This isn't needed actually, because what begin configuration says is begin configuration. It just batches multiple configuration options into an atomic update. So if you have only one, you don't need to batch. So that's a separate task. Don't call begin configuration. Wait, isn't that a bug? In this case, we are removing something, but in this case, we are not removing the photo output. So this is a problem here. Because what this function tries to do is, if you add a photo output, it removes a video data output. If you add a video data output, it removes the photo output. Otherwise it will crash, saying you can't have both. So this is a problem with the iOS camera APIs. They are too finicky, they are too crashy. They'll find some excuse or the other to crash or misbehave all the time. That's just poor API design. If there's only one thing to do, the API should do it. Let's see what the diffs are here. These are not logical changes. So let's take a look at this. Let's ensure that first we are configuring the device, then the session. Okay. We'll go through this view. Here we weren't. Now we are, especially since we are not using defer. So that's the other counterintuitive thing about defer. The execution order is different from the coding order. So it's hard to form a mental model. Okay. First you are configuring the device, then you are adding it. This is as clear as can be. Here the device doesn't need any configuration, so we are good. Here we are configuring the device, then adding it. Okay, great. So let's stage only this. The session should first configure the device. And notice that this is still a pending change. We don't know if we need it. We'll figure it out later. We can always commit it. Keep it pending till you need it. Alright, I think we have done enough work for now. I'll see you in the next video.